imagine you're a student, okay, traveling back home during winter break. And you're on the plane, and everybody can relate. You have an airplane buddy, and you have a strike up a conversation. So inherent in this conversation comes up an idea that pops into your mind just organically through this conversation, and you fly up, and now you're in the plane, you go to sleep, you wake up, and where did this idea go? So our solution is to capture that eureka, serendipitous idea and bring DOSA into the equation. DOSA is our degree of separation algorithm that we then will implement into connecting these ideas. So what we're going to do is go through the generation of our problem, where we started, how it was refined, what are our competitive advantages within the market, some validation provided with some testimonials, as well as a notional timeline and a summary at the end. So we're Team Jumpstart here at Johns Hopkins University. Next slide. My name is Dylan Richmond. I am a graduate student at the Information Security Institute.
Hi, I'm Keerthana. I'm a master's student in biomedical engineering here.
Hi, I'm Claudio, and I'm a PhD student in the political science department.
Hi, I'm Kaylin. I'm a master's student in the electrical computer engineering department.
Hi, I'm Kraicer, and I'm a master's student in robotics here at Hopkins.
So, our original problem. PACOM presented us with a problem of coordination between the assessment of the cyber indicators and the geopolitical indicators in order to better predict risk and predict the possibility of real-world attacks. So there was a problem of collaboration, and there was a problem of information gap inside of PACOM between the cyber analyst and the geopolitical analyst.
So what started out as a intelligence problem, we spoke with our sponsor quite extensively, and we kind of reached a stopping point to where a lot of the conversations we wanted to go to were kind of compartmentalized and classified. So what we ended up doing was we were pivoting, finding out, well, maybe is this an organizational problem inherent in bureaucratic institutions like the PACOM? This could be a problem. So, next slide. Where we ended up refining the problem was that maybe it's not so much an organizational problem we need to focus on, but it's something we need to be able to throw technology at and find us a problem worth solving.
So, yes, basically, we don't have the information flow between us and our sponsor that got interrupted. So with the advice of Professor Aronheim, he suggested to pivot the project and like redefine the problem in a way that would be helpful for us. So basically we addressed this idea of lack of collaboration, and we found out that in many business organizations, many consulting companies, there is this difficulty of collaboration and information gap between different departments, different projects, and different employees that work at different projects. So we said there are some platforms and some attempts to improve collaboration. What we could do more. So our idea was not just to improve collaboration per se, so not just to match similar ideas, but to improve collaboration in order to foster innovation. Basically, we were like, how can we replicate the experience of our group in a software, in a platform that could be easy to use? So one very quick example that will be analyzed later, if we have one field like medical that wants to perform an hip implant, and then we have in the motors the novel ball and the socket linkage, a better solution could integrate these two solutions in a combined and innovative solution.
So here we realized that the overall problem is that people have ideas and What they may not realize is the solution to their problem is something that seems like it's not really related, but ultimately it's really just a degree of separation from where their problem is, which is how we came up with DOSA, degree of separation algorithm. And it's a connection engine to foster innovation between problems that seem like they're not connected.
So as Kaylin said, we came up with this idea of a platform that will be easy to use. Here's just a little bit of images of kind of maybe what it would look like. It'd be mobile-friendly, desktop-friendly software where people could input their ideas and get matched to seemingly either different or somewhat similar ideas and solutions that might spark some more innovative approach to what they were originally working on. So a little bit of an example of what might happen. A user might input, or multiple users might input their ideas into the platform. We would extract key terms from those chunks of text and use a bag of words approach in order to match them and categorize them. And what would output from that are ideas that we match that are seemingly, maybe to the naked eye, not so much similar, but through our just one degree of separation might spark a new idea to what they were working on. So if we zoom in to that brain part over there, the degree of separation here is where we get those key terms from the text itself, but then we train a model to jump we train the model to look at those words and kind of get an idea of what could be related to those words with one degree of separation. And this could be something like you take the word chemical, and you might think of air, types of pesticides, disposal issues, side effects, and then also things like farmers in third world countries. You might think of things like less resources, animals, and so on. Words that are not there, but what a person might associate with those words. And then using those words that are a degree of separation away from the original, we will generate matches off of those. And those will give the results to the initial user and give them perhaps new ideas to what they were originally thinking about.
So what makes us different from what is already there? First of all, as we already said, it's not just collaboration, but it's just collaboration to improve innovation. So how to match different topics and different fields. We will use a large database of information taken from journals, public domain, website, but we will match them in an innovative way in order to foster creativity. There is an assumption, I don't know if it's accurate out there, that modern computing cannot be creative, cannot foster creativity, so our challenge is to challenge that assumption. So it will be a platform that will be very easy to use, it wouldn't be time consuming, and it would allow to save a lot of time and a lot of energy that actually is required in order to foster this creativity process.
Speaking of validation, this idea seems too wishy-washy if I don't really give a use case wherein this could actually be applicable. So here are a couple of use cases that we thought of. We do know that Hopkins is a huge organization and there's so many different groups and people working on multiple projects. Speaking from experience itself, say I'm a biomedical engineering student and I'm working on this project where I'm designing a hip implant. Now what happens if I run into a roadblock of thought process? In a very conventional setting, I would probably ask a couple of experts, get their inputs, brainstorming, and all that good stuff. But what about something like DOSA that could actually, in fact, reduce the serendipity that's associated with making such connections? In a scenario like this, there are so many different projects that are being put into the DOSA algorithm itself. And ironically, I might end up being mismatched, or in fact matched with the person who's working on a seemingly different project, but at the end of the day, it's the same. He's probably working on a ball and socket for motor. It's just that I'll be getting some sort of exposure or experience or insight, if you may, about the project that I might be dealing in. So we believe that DOSA could, in fact, help in cross-collaboration and just add a better perspective to things when you run into roadblocks.
DOSA would be very helpful in arts and sciences as well. So the academic job is like to connect existing theories and existing ideas in an innovative way, so you can actually publish some papers. So if we have like, one of the challenges in arts and science is to really create these new connections. So for example, if I have to connect economists or theories about political economy with no degree of separation, it would be very difficult to connect their theories just by themselves. While if I take some distance from the problem and add 1 degree of separation, in this case, I could match the more, like the closest concepts to each authors. I would get 1 degree of separation, I would be matched the law, so I would be able to match different fields in order to write a paper that might bring an innovative solution. In order to do this, this was an actual experience. It may take, it's very time consuming, you have to do a lot of research, it may take up to 2 or 3 weeks. I think that DOSA might really make the process faster.
So some of the validation also is helpful to have some testimonials with real people and not just us all in one group just running this idea together. Some of the quotes here are from the subject matter experts we went back to through our journey this semester with a listing of some of the existing applications. What set DOSAs apart is our unique approach and our connection engine. Next slide. And notional timeline here we said we could develop this product in 6 to 12 months based off of conversations with relevant faculty. We would deploy this within the Johns Hopkins network and then expand beyond that after our deployment.
So in summary, what is going to make DOSA different than any other tool out there that's available is our ability to foster creativity and innovation. So not just giving you a solution to a problem, but a solution that's innovative. And how do we have potential to be profitable? Every institution, every company across the world needs help with solving problems and getting innovative ideas. And who is our beneficiary? So again, everyone, students, people who work in the corporate world, and then people who are just working on ideas that they have and that they need solutions to.
So in the end, I believe that's an idea that in the end, I believe that's an idea that we think it's worth solving and worth solving the right way. And we'd like to thank Professor Aronheim, Professor Deborah. In fact, their guidance has been really valuable in really coming up with this idea. So thank you, one and all.
So I fully understand your pain crossing into the classified realm with the initial prompt statement. So I applaud your effort to rescope the prompt statement. I'm not sure if you have, but I think it would merit at least outbriefing the solution to your actual government sponsor, because I do think it gets after one of the pain points that you identified early on, the collaboration issue. And I've spoken at least an hour with the problem sponsor myself, but the ability to look at cyber intelligence and all the other forms of intelligence, which are completely, they don't talk to each other, and to pull upon those degrees of separation. So anyway, I think you're on to something. I think we're going back to your problem sponsor when you guys develop. Thank you.
Did you guys write any code?
One quick question. Did you think about other just different segments of kind of groups that would want to solve this problem? You have kind of a medical thing, kind of a school thing, and I mean, you might want to spend some time trying to look at that and coming up with the top 2 or 3 lists or some tests, kind of cases, so that we have something to run the stuff through and validate it, as opposed to just guessing.
And we just went with those examples just because that's what we had experience with. We kind of just thought, cool, this is what we would want it for. But definitely we can see from kind of the top market people to look into this.
So as far as bringing this to market, it might be a while off, but do you imagine this being kind of like a central platform that people can go in and sign into, or do you kind of like white label the software so each individual institution can have their own version of this?
I think that it would probably be something that people would go and sign into. That's what.
Yeah, I think we didn't like discuss this so much, but we have the idea it would be like an open tool that anyone can use, and then that would kind of help us kind of gather data and refine the model and see what works. And then from there, maybe we can make enterprise solutions.
You talk about pay comments and all that stuff working out there. In any given day, the command, there's some 20, 40 meetings, and one of the issues that Tom brought up is, there's lost connections, and people often can't be at the right ones at the right times. If you use like a cell-based security thing like a Cumulo or something like that and built it into this, that would allow compartmentalization at the right level for the right person with the right data that's there. And that office that is behind 5 different closed doors that have different security requirements, they may not necessarily know that you're looking at this, but because it's broken down at the cell level, you don't have access to work on something like that. So just be something to consider moving forward. It's one of the ways, and I know that we talk to our software engineers, and that's how we do business with Cumulo. It's an easy way to protect things at the right level.
Thank you.